Hi girls. Sorry I got coaching today, so I can't be there with you. So I have decided what we do today will be doing some revision on integration first, and the second half of the lesson I will give you time to do the homework you're missing. So I'll probably spend the first 15 minutes to go through some of the integration questions with you, and then you can use the rest of the time to do your homework before. So to start, I'll go with some questions like this. Okay, so first one, they are all definite integral, so therefore that means you need to substitute values in. So for part A, it's pretty straightforward. Integrating from 0 to 2, x cubed minus 1 dx. Now this is a excuse me, this is a linear function, therefore you can integrate it separately, which means it's x4 on 4 minus x. Remember, the derivative of x is 1, so when you integrate it 1, you get x. And then you substitute the values in using the fundamental theorem of calculus. So 2 to the power 4 is 16 minus 2 minus 0. Simple answer. Therefore, that it's a minus 4 minus 2. That's just give you 2. Nothing difficult. Part B. So from negative 1 to 1, x to the power 5. Now, here's another thing. Now you can evaluate this using a normal definite integral. However, we know a property called symmetrical property. That is, from negative a to positive a of fx of dx. If there's something special about this fx, which means if it is odd or even, then we can apply some special property, especially when this is odd. Since x to the power of 5 is actually odd, therefore 0. Since y equals to x to the power 5 is odd. So this is the symmetrical property. When the inside function is odd, if you integrate it from negative a to positive a. Part C. Now, this is raising power to a linear function, 3x minus 1 to the power of 4. So as I've mentioned before, this is a simple example of reverse chain rule, which we're going to do later on next lesson. So in this case, we can't integrate it straight away because it's not ready, technically saying. We need the component for us to actually integrate this. That is the derivative of 3x minus 1, which is 3. That is your component. You need that to integrate for your integration. And you can't just make the 3 there. Therefore, you need to divide it by 3 outside. And now it's ready to integrate as a whole thing of 3x minus 1 to the power of 5 over 5. Remember, at this stage, you have consumed the component 3. That means it's gone. That is 1 on 15, substituting 3x minus 1 to the power of 5 from 0 to 1. And that will give us 3 minus 1, that is 2. 2 minus 1 to the power of 5, 2 to the power of 5, that is 32, minus 0 in, negative 1 to the power of 5. That is 33 over 15, which is 11 on 5. Okay, so a few different techniques we have done in question 4. So some property and including the general way of doing this kind of question. Next, find the area Find the area bounded by the curve y equals x squared, the x-axis, the line x equals -1 and 2. First of all, of course, we need to draw that first. Parabola bounded by the curve, the x-axis, and the line -1 and 2. -1. That means it's this area, everything underneath. Okay, so we use integration for this. So area equals to integrating from -1 to 2 x squared dx, which is x3 on 3, -1 to 2, and I'll substitute, I'll take a third out. That's 8 minus -1. That will give us 3. Don't forget, it's area, therefore unit square. Nothing fancy. We have done this in class, so not that difficult. Now, what's the next thing we should do? Let's do a Simpson's and trapezoidal rule, which is just exactly what we did yesterday. All right. Let's do Simpsons first. Use the Simpsons rule with 5 function values to find the approximated area enclosed by the curve y equals 1 on x and the x-axis between 1 and 3. We have done a very similar question yesterday, but this time the boundary is between 1 and 3. Again, this is a hyperbola. Sorry about the sketch. One and 3. And we need 5 function value. That means you need 5 points on the curve, and they have to be equally spaced. And I don't think we will have trouble of separating these 5 points. Therefore, this is 1.5, 2.5. In other words, 5 function value again for Simpson's rule, that means 2 applications. That also means 4 subintervals. So the way of doing Simpson's rule would be, we always start with the table, fx, or you can just use y in this case. 1, 1.5, 2, 2.5, and 3. Substitute 1, half, a third for that. And then the reciprocal of 3 on 2, that's 2 on 3. The reciprocal of 5 on 2 is 2 on 5. Okay, so therefore, if we want to find out the approximation, so this time, the question asks us to approximate the area. So we are in fact finding area this time. Don't forget the unit square at the end. So area is equal to integrating from 1 to 3, 1 on x dx. Remember, this part is actually exact up to this line. However, if we don't use integration, using Simpson's rule, the next line becomes an approximation. And remember, the Simpson's rule said, if I'm integrating from a to b fx dx, that is b minus a on 6, f of a plus 4 times f of a plus b on 2 plus f of b. So in this case, because we have 5 function value, we need to apply Simpson's rule. Oops. We need to apply Simpson's rule twice. One here, the other one here. So therefore, we have 2 minus 1 on 6 1 plus 4 times 2 on 3 plus a half plus 3 minus 2 on 6. Remember, these two must be the same. And the other one is half plus 4 times 2 on 5 plus 1/3. And then the rest is just calculator work. You just put it in a calculator. As expressed as a fraction, since the question doesn't ask us for any approximation. Okay, so remember that is Simpson's rule. 5 function value means 2 applications. Okay, let's have a look. Next question. I saw an area. Find the area enclosed between the curve y equals x squared and 2 minus x squared. So this time is area between the two curves. Y equals x squared, concaving up parabola, and 2 minus x squared, concaving downward parabola with y-intercept 2. By the way, the x-intercept is supposed negative 2 if you're interested. So you're looking for this area. Okay, so let's take a look. So first of all, in able to do this, we have to find out the points of intersection because that's where your boundary would be. So in this case, to find out the points of intersection, we need to solve them simultaneously. In other words, let x squared equals to 2 minus x squared. In other words, 2x squared equals to 2, x squared equals to 1, x equals to positive negative 1. Therefore, that here is 1, negative 1, and 1. To get rid of this now. That's negative 1, and that's 1. So therefore, now remember the area bounded by any two curve, it's the top one minus the bottom one, and then integrated. Therefore, the area is bounded from negative 1 to 1. The top one, which is the concaving downward parabola, minus the bottom one, dx, which will give us 2 minus 2x squared dx. Take out the 2 as a common factor. That's easier for our life. Integrating 1 and x squared minus x cubed on 3. Sorry, that should be x. From negative 1 to 1. Oh, by the way, this is an even function. Therefore, if we would like to apply the symmetrical property, it would be actually easier for us. I'll just do it. So in this case, this part, if you take the 2 out, let's do it again. 1 minus x squared dx. Since 1 minus 2x squared is an even function, that means that becomes twice from 0 to 1, 1 minus x squared dx, which will make our life a bit easier when you do integration. That is x minus x squared 3 on 3 from 0 to 1, 4, 1 minus a third minus 0, and that will give us 8 on 3 unit square. Okay. All right. Do we have time? 1 more minute. Any volume questions? The line y equals to x minus 3. That's 3 on 2. It's rotated about the x-axis from 0 to 3. From 0 to x equals to 3, find the volume of the solid generated. So therefore, it's this area until this area. So therefore, there are two parts of the volume. One, basically the same thing. You can just integrate it from 0 to 3. Remember, you're squaring the function, so it really doesn't matter positive or negative. From 0 to 3, pi 2x minus 3 all squared dx. So you can continue with this yourself, girls. Bye.